We've got a new face on the webinar with us today, Baydaa Al-Zubaidi, and she's a senior network consultant with Bell Markets, which is part of Bell Canada. We're very excited to have her here today, and we've been giving her shout outs for weeks leading up to this. I feel like we've been talking about it for a long time. We're really lucky to have her, happy to have her here. My name is Don Cook, I'm the Chief Marketing Officer. With you as always, as are Heather Dremel and Jim Vada. Jim, our Chief Wireless Engineer, CWNE 183. He's our resident expert Wi-Fi engineer that joins us week after week after week. And Baydaa, I'm gonna hand you the controls while Jim gives us a more formal introduction.
All right, thanks, Don. And like Don said, we're really pleased to have Baydaa Al-Zubaidi with us today. She's got a broad range of enterprise Wi-Fi experience and certifications from CWNP, from Cisco, in route switch and security. And it looks like, Baydaa, if I'm correct, maybe you're working towards a CCNP certification too. Is that right?
In the plan, yes.
All right, yeah, definitely. I see that encore on your resume there, so looking forward to it. She's worked with healthcare customers, education customers, government customers, and a lot more. And she's a teacher, and we're ready to learn from you, Baydaa. So I'll turn it over to you.
Thank you. Good to be here. Thanks, Don, Heather, and Jim, for your introduction. Thank you so much. So I believe we're done from this. Okay. So today I'm gonna talk about my personal experience while handling wireless projects from A to Z. And as you could tell, the agenda has many topics, and it drive you through implementation of wireless project from A to Z. And basically the key point that I want to talk about here is communication and collaboration between different teams involved in implementing wireless project. So the agenda will cover the wireless project requirements, our design options, information gathering, our design report, cabling AP mounting team, implement the wireless solution, post-exit survey, while on site, start the exit survey, how to do post-exit survey, post-exit survey report, and the most important is the communication and collaboration, conclusion, and Q&A at the end of the presentation. So, starting with wireless project requirements. Basically, we start with meeting the client through the kickoff meeting and to understand the project scope and identify the way to handle the project. So starting with the scope of wireless project, is it a new site? Is it an expansion of a current site? Is it an upgrade to current wireless? Sometimes the client asks us to do one-for-one replacement. For one replacement, if the client has issue with current wireless coverage or connectivity, then this will not work. So clients should be educated to understand the risk. Maybe need to work in stages if budget is an issue. Partial replacement, better to replace all the APs with a new one. We know that all system will not utilize the new feature. Complete replacement, which is the one that I love, greenfield. Basically, you start from scratch. We need to understand the site type. Is it a standard office? Is it a heritage building? Is it arena, hospital, school, parking lots, outdoor coverage? Indoor, outdoor, or both in terms of coverage requirement. Because each of these require different way to handle your RF design. We need as well to collect up-to-date scaled black and white floor plans, and the client need to identify the required coverage area and also any excluded area. Client to identify AP location restriction. For maybe security reason, they don't want to have the AP installed in certain room, or maybe for decoration reason, or we need to know, okay? This will, at the end, save the client time and money. Now, RF design options, taking in consideration the building type, again, if it's heritage, if it is standard office, the client need to decide which solution to use for the wireless RF design. Of course, if it is a heritage building, I will definitely go with physical site survey, to be honest. Sometimes the client has not enough budget to handle the physical survey, site surveys. So in this case, you might go with partial or hybrid site survey. So that means you start with the most problematic area, you take samples from there, and then use this data to do the predictive. So it's going to be hybrid. Or if the site is just a standard and you just go with predictive site survey. For me, when I do predictive site survey, I prefer to visit a site and take pictures. Usually I visit with a draft, with my draft design. So I take picture, I decided if I need specific mounting kit, what type of ceiling I have in place. So all this will help me generate accurate report, which going to help team, the cabling team and the AP mounting team to do their job better. Of course, while you decide on which type you're going to go to start your design, you need to talk to your client. You need to educate them. They need to understand the risk and the consequences of each method, so they could take their right decision. At the end, I believe most of the time budget is the controlling the decision. Information gathering. So definitely when you design your RF, you need to know the number of users in per floor, per building. What is the type of application? What is the wireless vendor? Am I going to go with Aruba? Because when you design, you need to select your AP, right? You need to know if it's indoor or outdoor, so you could decide on antenna type. If the requirement, if there is a voice requirement, if there's a location tracking. So you need to know which location tracking solution the client going to use, and you go review that the guide for that location tracking solution to know the requirement, so you could implement it in your RF design. Always follow the vendor basic practices for RF design. Outdoor design requirement. So for outdoor design requirement, you need to identify the location of the portal point. This one needs to be close to the main building to run LAN cable back to the building. You could use building construction in order to mount that AP, assuming that this is not a heritage building. And also we could use the light bulb to mount the mesh point, as well as to have the power source. We need to use, in this case, secure enclosure or NEMA standard to protect the AP from harsh weather. Look for obstacles around. You know, it's different in summer than winter, for example, the trees. Other network around the location, interference. If the outdoor location is close to water, so think about humidity absorption. So this is all about outdoor design requirements. Analyze the collected physical and partial survey data to select the best location for the access point. Of course, when we design it using 5 gig requirement, and you need to use a scaled floor plan. So sometimes the received floor plan has dimension on them, or they could have a scale. So anyone gonna work. Once you design using the tools that allow you, for example, Ikahal, once you finish, you're gonna need to generate the submit the report. So usually we include in that report AP location. Okay, so the green dot here shows the AP location on the floor plan. Type of mounting kits, very important. If required, take picture for the AP location. Mention that this AP going to use this type of mounting kit. Clear with easy direct note for cabling and mounting team to read. Note for cabling team, yes, we mentioned that. And if the client has any restriction in any area of the floor plan, you need to label it there as well. The most important RF requirement, for example, signal strength, signal to noise ratio, network issues, and more. Sometimes the client might ask you for certain type of sections to be added to your report. Sometimes you advise the client, it depends. Cabling AP mounting team. So usually the cabling team will receive the RF design report. They're gonna run the cables to AP location according to that RF design report, which gonna include all the details that they need, including AP high, cable length, okay. While on site, if any issue encountered during the cable installation, the cabling team must report it to the RF design for consultation. So sometimes, specifically if it is a predictive survey, so the report will tell you mount the AP here. When you go to mount the AP, you're going to see it's like a metal door, right? If we look at these samples that show you how bad it is, as an example when mounting the AP. So the first left picture, it shows you that AP installed above construction. In this case, you could easily use this type of mounting kit. It's 900-HC-WH from Oberon, or any different vendor that is give you the same idea. So you could basically this mounting kit designed to mount the AP directly to conduit, hanging from ceiling and below any construction. So basically you need to install below that red line you see here. Next picture, the AP is another bad example of AP mounting, which is basically it is mounted close to metal door, could be maybe close to glass door. In those cases, you're going to have a RF reflection. So you need to consult with the RF designer to decide where to install this AP. Or AP might be installed close to fluorescent light. So you need to at least to have 3 feet away from any building construction. Another bad examples of where the AP is installed. This again, the pole mounting kit will work better in this case. This one, it's really funny. AP11, this one should go inside the room, but cabling team didn't drill through the wall, and they decide just to put it here without consulting with the RF designer. So at the time of post-exit survey, when we discovered there is basically completely no signal inside this room, we asked Hussein to provide a picture. We found that, oh, this AP is completely in wrong location. So to fix that, we drilled, we pushed the cable to inside the room, and we put the install or mount the AP inside the room. And then the post-exit survey passed. This is all consume time and budget. It's not going to be on time. It's not going to be on budget, and delay the project. And of course, miscommunication. So if any of the team report that ahead of time to the RF designer, we could find better solution. Outdoor coverage. In this case, it should follow the vendor requirement to terminate specific type of cable. So this is an example of wrong installation. Basically, the NEMA standard is not followed. Installation failed after 2 years. This white box wasn't protected by the junction box. So it should use this watertight junction box and should be sealed after to prevent moisture or water from leaking inside. That is the way to solve this issue. You could tell here the RJ45 get corroded. Okay, so again, consider NEMA standard when mounting the AP to protect the AP from harsh outdoor environment. Implement the wireless solution, assuming that once we provide the report, AP cabling team run the cables, AP mounting team run the AP, the client configure and implement the solution, all APs is broadcasting the SSIDs, everything is fine. So it's time for post-exit survey. To be prepared for the exit survey, we need to use the tools. So whatever. So Cyclic, for example, prepare your laptop or tablet. You need to use up-to-date EcoHouse software and drivers. You need to use the EcoHouse source file, which is going to be provided by the RF designer. And definitely you need to review the RF/cabling report before doing that. You need measurement tool as well. You need to test the devices and tools before showing up on site, right? For example, download the EcoHouse source file, provided by our designer to the tablet or laptop, review the EcoHow source file and the cabling report, contact our designer if you have any question. There's no problem from asking questions. Question is a question. There's no bad question or dumb questions. Okay, so while we're going on site, you're gonna before you start the exit survey, you need to perform. You need to confirm certain item. For example, just have a look at the APs. Make sure that they're all on. Okay, APs placed in the right location, right? Following the RF design document. Floor plan and layout, there's no, doesn't match the RF design floor plan. Are there any issue? Okay, report all issues immediately to the RF designer. You might need to send pictures, right? If requested by the RF designer. It's very important to ask the client for permission before taking any pictures. Sometimes from security perspective, they don't allow you to do that. So, look at the LED on the AP to make sure that it's up and running. Check for any unusual construction while working, while doing the exercise survey. And specifically when you are doing predictive RF, so you're not that much familiar with the environment. Okay, so when you start your exit survey, make sure that your mobile hotspot is off. Collect the data for the required coverage area. You need to send the file to the RF designer to validate it, and then if issues are found, you will be provided with instructions to correct the issue. Maybe you need to revisit an area to collect more data. Maybe you need to validate wall type. Maybe you need to take pictures. Okay? So you keep repeating the above step until all floors have been completely surveyed. I believe this is important note, which is if you're going to collect data from more than one floor, then try to append a version to the file name before sending it for validation. You could also put your mobile device in airplane mode. So, Jim, are we okay so far? You need to have are there any questions, or shall I keep continue? Or?
Yeah, we're doing really well. One note I would add too is when you start this survey, and I've made this mistake, that's how I learned. Make sure if you have Bluetooth devices or a smartphone on you, put those in airplane mode, because if you're doing spectrum analysis at the same time, it'll just light up your spectrum analysis and cover up everything else going on in the environment. We do have some questions coming in, but maybe we can tackle those when we finish up here.
Okay, thank you. So how to do post-exit survey? It's very important to be ready. Like ensure that your exit survey tool are working properly and the EcoHow version is up to date. Turn off your hotspot. Your PC or tablet must not be accessing the internet during the exit survey. Ensure that your devices are fully charged. Ensure that your devices are fully functional, right? Many times the technician go on site and, oh, my laptop is not working, or, oh, I don't have my second charge and I need to wait for 3-4 hours to charge my laptop, something like that. So ensure that you are using the right files provided by the RF designer. Select site survey type, which is active survey or passive survey. Turn on the devices, sound to alert you if site is disconnected. Perform the exit survey, stay within the coverage area. Now, Heather could copy the link for a blog to talk about or to explain the difference between active survey or passive survey.
Yep.
Basically, yeah.
So
Yeah.
check the chat, guys.
Yeah. So sometimes the client asks us to go with passive survey. Sometimes the client say no, I need active survey. It depends. Sometimes you advise the art designer advise the client where to go. Basically, if you want to listen to the environment, collect interference, log APs, signal strength, noise level, SNR, that's when you go with active, sorry, with passive survey. And also, if it's easy to maintain the same speed while walking. The other way, which is active survey, it's when you connect your wireless adapter to the wireless network. And this time when you need to collect round trip time, packet delay loss, performance, data upload and download speed, okay? But that's going to be only for the connected wireless, no other Wi-Fi, which means no interference info, okay? So, okay, so basically when you start the exit survey, you open the provided exit survey source file. We always ask technician to scale the floor while on site. Okay, so even if I provide the file which is already scaled, I always need them to confirm again while they are on site. Measure the wall that's at least 20 feet if possible, depending on the floor side, and update the ICAHO file and save it. Now, best practice to measure the longest wall, for example, corridor, specifically for large floor plans for accuracy. Consequences from failing to receive the latest up-to-date floor plan. We could have a cabling issue, right? We could have AP location issue. We could have failed post-exit survey and post-exit survey report. Of course, again, project delay and over budget. Signal prediction. If you're going to do exit survey, you need to make sure that signal prediction is off. So you go to option and turn off the signal prediction. Again, for the type of exit survey, you could use either continuous or stop and go. Heather, could you please paste on the chat the link to show the difference between continuous and stop and go?
Absolutely.
Sometimes you could go hybrid. So, for example, big area where you could maintain the same speed when walking, or a long corridor, you could do continuous. If you enter a room where it's filled with furniture and there's no way for you could maintain the same speed while walking, you could at that location do your stop and go. Sometimes the client asks you to do continuous survey on, so depends. Okay, so to prepare the tool, you need to make sure, if it's passive survey, you need to make sure that to disable your internal wireless and make your passive for the sidekick. Channels by default, the default system is collecting all channels. So keep it to the default. The thing that the technician who's going to do the exit survey need to make sure that to correct the AP location, because the auto AP placement algorithm place APs along the path, the survey path. This may not be an ideal location, so correct it. Just drag and drop the APs to where you see them all, in that location. It's the tool allow you to add nodes, and I believe it's very important because while you are working, for example, let's say they move a door from its original location, or there's a new wall been added, or there's a wall been removed. So just put these nodes right away while you are doing the exit survey. Of course, the tool need to be configured for coverage requirement. So 5 gig setting, 2.4 setting, legend setting. You select your 5 gig, and you also make sure that the coverage area is using the coverage requirement. So when you collect the data while doing the exit survey, you could right away know if the area is failed or passed. Post-exit survey report. So RF Designer perfectly RF Designer received the exit survey data, start analyzing it, and start using the template to generate the report. The report could include required coverage area, AP location, path for the post-exit survey, heat map for signal strength, SNR, signal to noise ratio, network issue, etc. Could solve the client requirement in this case. Other APs collected by exit survey. Client to investigate those APs and remove it if it's not belong to their network, and list and name of the devices, and any recommendation depending on the data analyzed. Communication and collaboration. So teamwork is a key for successful WISE project. Failing to communicate and collaborate between teams, which means project manager, RF designer, cabling/AP mounting, and implementation team, will result in many issues, such as cable deployment. So again, this is yeah. Yeah, so cable might deployed and terminated in wrong location. Basically, the cabling team saw some construction in the AP where the cabling, well, the RF design document recommend, and then they decide by themselves to put it somewhere else. The example that I talk about it, I have a dome where the AP should go inside the room. There were concrete walls between the corridor and the room. Basically, the cabling team did not drill through the concrete, and they just terminate the AP in the corridor. So AP mounting team, they start mounting the AP, and then they didn't review the RF design. And they just decide, oh, that's where the cable get terminated. I'm gonna mount the AP here. And when we, at the time of post-exit survey, it's failed inside the room. So again, send the team again, they drill through the concrete, fish the cable inside the room. So AP mounting, same issue in here. So that same example shows that AP been mounted in a wrong location, or maybe mounted around construction. So you need to stay away at least 3 feet from fluorescent light, from havoc, from any metal, you name it. Wrong mounting kit. I have a good example for wrong mounting kits. So yeah. So as a result of not reviewing the RF design report, the wrong mounting kit ended up being used in a wrong location. According to the design report, the secure protected mounting kit must be installed in the gym area. Okay, and unsecure, unprotected one must be installed in other areas. Of course, to fix this and to save the wall from damages, I decided to order a new secure mounting kit for gym area. So again, not going to be on time, not going to be on budget. AP not broadcasting the SSID. Okay. Usually before sending technician to do the post-exit survey, we always communicate with the client to ask, are the APs up and running? Are they broadcasting the required SSID? So when we get confirmation, we schedule the technician, we send it to the client side. When they start to capture sample and send it back to our designer for validation, figure out, oh, there's nothing. There's the SSID that the client told us that we're gonna found. It's not there. So basically, talk to the client, check. It could be many issues. Could be that's I'm talking here either a full site, so all the APs is not broadcasting, or could be partial, like a couple of APs not broadcasting. So it might be a configuration. Let's say the APs can't find their DHCP. So maybe the DHCP scope wasn't configured right. Maybe IP helper on the router configuration is not there. Maybe missing a route between the AP and the controller. So any of these issues, maybe instant AP missing some configuration, maybe PoE, right? Injector, maybe wrong PoE, PoE plus first PoE, maybe switchboard configuration as well. So any of these will fail the post-exit survey. The post-exit survey could be failed due to building material or change in floor plan layout or furniture. So all these gonna definitely required rescheduling. It may delay the project and it's gonna be over budget. So as a conclusion, successful wireless project require teamwork, require communication, collaboration, responsibility and accountability, okay? Which at the end affect time and budget, and of course will produce a quality when performing wireless implementation. The last thing before going to Q&A, I want to tell about my recommendation as an RF designer. In order to work in this field, you need to have a solid base in network, wireless, and security. You need to attend webinars, need to conferences, read white papers, register in the vendor community site, always following the basic practices from vendors, and always ask questions. There's no shame from asking questions. There's no dumb questions. A question. There's no dumb questions. So I hope I add something to you guys, and thank you for having me here.
Yeah, thanks a lot, Baydaa. And I'll just echo that. It is a lot better to ask questions than to learn in the field when time and budget is on the line. Better to ask a question before, get it clarified, and do the job right the first time. So we've got
Sure.
some good questions from the audience. I think we have maybe time for one or two before we go into 7 minutes of 7 signal. Baydaa, Dave has a question for us. He says, what's your opinion on one-to-one replacement with a newer PHY technology? I guess he means one-to-one AP replacement. My personal opinion is if I'm going from 802.11ac to 802.11ax, I would need more APs due to the SNR requirements to gain the maximum efficiency from the new AX APs. Any thoughts there?
Well, I'm the one that do not like to do one for one. It's very complicated because from the design itself, it's different from designer to designer. Like if I do the design myself, I'll do it differently from my brain is work different than others. Okay, so you put the AP here, I might put it somewhere else. That's by itself. It's an issue, right? So when you take the project, somebody else been designing it at certain time, I believe it's going to not work when you take it after a couple of years and you want to redesign it and you want to implement the new technology. Unless there is really no coverage issue whatsoever, no client suffer whatsoever from connectivity everywhere, then I will be okay and comfortable with one for one. Otherwise, no, I will do a fresh installation.
Yeah, there's a good chance those new APs have, different antenna patterns, different coverage patterns, and it's definitely worth redoing it. I would also add too, it's true you need more SNR to get the higher data rates in 11AX, but do you need those higher data rates everywhere? Or is it just okay to have them in the area closest to the AP and then, more reasonable data rates in areas outside of the AP? As long as you're still meeting your application requirements, that's probably a good approach. And the other point in that question, Dave, you did mention maximum efficiency. And one of the nice things about 11AX is with OFDMA, there aren't SNR requirements for that. So distant stations that don't have a lot of SNR can still participate and gain the efficiency that OFDMA allows for.
Yeah, I believe also the application that the client going to use, like the requirement for this application is changing every day. So I can't install a new network for a new client with back. So it's definitely you need to take in consideration everything.
For sure. And maybe one more question. This is from Vasileios. Hopefully I got that right. And the question is, when creating an RF report, would you suggest generating many different scenarios for airtime utilization using different devices/profiles in numbers? So I guess what is the scenario you would use for that when doing airtime utilization sort of modeling?
Well, I believe I will leave that for Jim.
Yeah, I think.
Any thoughts on that, Jim?
Yeah, I think two things come to mind. One is kind of doing a typical scenario, which is what's kind of the day-to-day going to look like in terms of the devices, the number of devices, and the applications they're using for that. I mean, your design should handle that easily, of course. So what's really valuable is actually doing a worst case scenario. What's the maximum number of devices that are active using the most demanding applications, and see how the model holds up to that. If that works, then there's a good chance the Wi-Fi network is going to meet requirements pretty much all the time.
Mhm.